And next, I'm very excited to invite our co-principal investigator, Dr. Bjoern Peters, who has very diligently behind the scenes been responding to a lot of the questions that we didn't get to in the Q&A as well. So thank you so much, Bjorn, for doing that. And we'll spend the next little while giving an overview of the analysis resource, which we do go into a lot more detail for day two. And then Alex will touch on the analysis tools, which we'll just discuss on day one. But with that, I will hand it over to Dr. Bjorn Peters to present the analysis resource overview. Thank you, Bjorn.
Awesome. So it's my pleasure to talk today about the analysis resource. Overall, um, this is a two-part presentation. Alex is going to cover the analysis tools, like Nina was saying before. And for everything that I'm going to be presenting, as Nina was just saying, but I'm going to have to stress it again, day two will go into much more detail. So to a large extent, my presentation today is meant as a overview of what is available and the kind of components that we are providing, but it does not provide the level of detail to answer specific questions of how to use specific tools. And I would ask you to, um, I mean, maybe we can get to some of these, but probably the best venue for questions about specific tool usage will be tomorrow, where we can go into much more details into individual tools. And today is going to be the overview of what's available. So again, Alex is covering analysis tools, which is like dealing with when you have epitope sets in hands and want to analyze them in some way, versus my part is about prediction tools, which are essentially tools that we are basing on machine learning techniques, where we take the experimental data that you have seen is being cataloged in the IEDB in the previous presentations. So we use that data that is cataloged in the IEDB as training input for machine learning tools. This example I'm showing here is MHC binding data because it's the easiest to understand, where you have peptides with measured affinities, say, and then you can apply various different methods like neural networks, linear weighted models, anything to extrapolate the patterns that you find in your data to then arrive at a prediction model, which you can use for any kind of new sequence inputs and get out new predicted affinities for that. So that's prediction tools, and throughout there's many different ways of how to generate prediction tools. So one key question that we've always been asked is which one we should be using. So another key thing that the IEDB is attempting to do is to provide benchmarks that evaluate all prediction tools that we have available and give guidance on what we consider to be currently the best prediction tool available, and those things change over time. So I'm showing here an example of a benchmark where we use different MHC binding predictions to evaluate the ability to identify T-cell epitopes in a vaccinia virus mouse challenge model. And then you see your different ROC curves. The higher you get here, the better you are, that distinguish different performance of different tools. And that kind of benchmark using data sets that have not been involved in the training and assess the real life capability of these tools to work is what we're using to make our predictions. So the other thing I have to stress is that we kind of currently are in a transition state where we have the IEDB tools as they have been existing for pretty much 20 years at toolsidb.org, which is the what we at this point call the legacy side, compared to the next generation side, which has been an effort that we started in 2023, which has been re-implementing all the tools that we have, not the underlying algorithms, but the website exact access to the users to address the kinds of comments and requests we've been getting at workshops like these by people to make it more easy to use, and also like based on help requests and user testing, etc. So we have at this point two sites side by side. One is at tools.iedb.org, that is the traditional site, and then we have next-gen tools at iedb.org, where the new tools are available. So talking about the next-gen site first, here is an example of how the um, T-cell tools look like. So this is the page that you're getting when you get there, and this immediately, for example, allows the user, you see here in grayed out kind of the text of a sequence and an allele, and you can just hit go and you get an example here. You get an example run on the class 1 tool, class 2 tool. We found that it's actually very useful to always give a direct example of how to run something and then change it rather than giving blank boxes where people say, what am I supposed to put in here? So the results page then that you're getting here is this kind of overview of what you did. Like this is the input sequences you provided. This is the HLA allele in this case that you provided. And now you can change these things. You can change the input parameters such as the length of peptides that you considered in your predictions. You can change the prediction method. In this case, this is the recommended based on the recommended predictor based on these kinds of benchmarkings that I mentioned before. You can combine different tools. This has been a key request over and over. We routinely, when we use prediction tools, we chain different tools together, such as like a redundancy removal to the output from a MHC binding predictor. And you can do this by essentially getting the results from one tool, piping into the other. That's what we call our pipeline of tools. And in these analysis tables, results tables, you also have the ability to like filter and export, obviously, as before. So, as I mentioned, we started this in 2023. That's when the first site became live, implementing the first set of tools. And we are in this transition state where we have been gradually moving over, and we are on track at this point to the release 4, which should be happening early 2026, when the B cell tools are going to be added to this page as well. So currently everything is T cell centric on the next gen site. Here in release 2, we added a number of cancer specific tools, which are provided by the CEDAR effort, which you're going to hear more about in day 3. As you may or may not realize, that lots of the users of the IEDB actually have historically been interested in doing cancer immunology assessments. So in day 3, we're going to go into detail there for both the database and here is where the tools have come in, and we're combining them because many of the tools that we have, say MHC binding, are equally used in fields of cancer or outside of cancer. So again, this is the how the homepage looks like when you're getting to the next gen tool site. There is, similar to what Kelly presented for the database queries, you can run tools through an API. And if you click through that API link here, you're going to get more information how to do that, how to call the API, what the endpoints are, and there's help and contact things in here. So this is something we are really excited about. We are hoping to be able to, you have this ability to build pipelines, persist them, modify them, call them through code. We are really hoping to be able to integrate the kinds of tool sets that we've been providing for a while into the general bioinformatics workflows that are out there. So the other thing is, again, if you're on this page, you can click on Tools, Help Info, and under Tools, you actually get directed to the different sets, classes of tools. But also there's an all tools list, and that's what I'm showing here, because one of the things in the previous in the legacy site, one of the issues that we have run into is that over time we have added more and more tools that essentially do something very similar, and we now have been combining them and saying these are all the MHC1 related prediction tools. But there's different tools than essentially provided using drop downs on the same page, and so they're not as obvious to the user. Maybe if you go to this all tools list, you can find them directly. Versus at the same time, we providing the same input and output pipeline to access all the tools, which allows you to easily change and modify pipelines and go from one tool to the other. Under help and info, you're finding tools documentation similar to what Lindy has just shown you for the general IEDB database side. We have tools documentations here that allows you to search as you're expecting and obviously ask questions, etc. Very similar to what Lindy just showed for the database. And obviously, this would be a great place to get started if you're unsure about anything. There is a CEDAR page. This provides information about the papers where the different tools are described. So obviously, if you're using one of the IDB tools in a paper that you're writing, we very much appreciate if you can cite us. That is the currency kind of by which we are being evaluated for the usefulness to the community. So, I mean, obviously, use them, and if you find them useful, please cite us. Actually, even if you don't, just cite us anyway. Um, Licensing. So, we have been finding out that for a lot of companies, there are restrictions on what tools they can use because they are limited to where they can say if they're working on a protein drug, um, they are restricted of not disclosing that to any public website, and IDB is very much a public website. So if you want to work with tools behind your firewall, the best way of doing that in a commercial setting, the best way of doing that is to get a license, download the tool, run them on your site, and in general, the tool licensing is providing essentially additional funds that also allows us to provide more help and more support for the downloadable tools. If you're working with it in a completely academic setting, you can just download them and it's fine. But we very much appreciate the commercial customers that are out there and that have been using it and have been providing significant funds to allow more resources for help and customizing and error fixing that we would have otherwise not been able to do specifically for the downloadable version of the tools. Contributor tool. So the IDB has always been intended to host any kind of tool that is relevant for epitope specific data. And if you are a tool developer and if you are interested, please consider contributing the tool. I mean, this is something that I've been always been a little bit amazed that it has not been picked up so much. People still want to publish on their own web server. And if you're a tool user, you know the frustration of going to a paper from 3 years ago and it might have been a PhD student and he's no longer there and the server is gone. So we are trying to provide a persistent platform in which tools are going to be accessible. We are not claiming any credits to those. If you have a tool that is useful to the community, please contact us, please contribute it. And that doesn't, you don't lose any ownership. It gives you a much wider reach of your tool. I mean, we have over 1,000 users a day at this point. And it is not just that you get exposure to your tool, the and also a larger usership, and hopefully you should have less of a hassle with maintaining it. Specifically, if you're, say, a PhD student and want to at some point move somewhere else. So, getting started. summarizing kind of this part here, if you're interested, start off at the next gen tools at .idb.org and check out the website. If you are looking for a specific tool, try that all tools list. You can filter that down by different categories and find the ones that might be of interest to you. If you're specifically a programmer and want to integrate these tools in your programs, check out the API, look at the documentation, try it out if it works for you. If you need any help, there is the docs site, the help site that I showed before, where you can search for existing things and ask new questions. And then if you want to download the tools, as I mentioned, we have them in the download all section here. So everything I've talked about so far was about the next gen site. But again, we have the two sites, the next gen and the traditional analysis research page that has been there before. And as I mentioned, we have not transitioned completely. So specifically, if you're interested in B-cell epitope prediction tools, that is currently the only place where you'll find them. Hopefully, a month from now or so, that'll be different. So this classic analysis resource, if it is still accessible, it is the main thing that you guide it to because it's the one that is complete when you start from the IEDB homepage. Toolsidb.org brings you to this page that gives you the summary of all the tools available. And essentially, they are separated into T-cell tools, B-cell tools. Both of those are prediction tools, meaning that they are based on machine learning, like I said in the very first slide, trained on existing data and trying to extrapolate from that data to make new predictions. And then there's analysis tools that Alex is going to talk about right after me. Here, there's a separate API to the traditional analysis results tools that you can find directly on this tab. There's a download tab to get to the standalone local versions of the tools. So all of these things are accessible there. And actually for the standalones, they're going to be largely overlapping. But over time, we're going to transition away from this to the next gen tool site. There's data sets available that are actually used for training and evaluation. And you can get help through the Solution Center or contacting directly through our help email. Just going quickly through the existing classic tool sites, the T-cell epitope prediction tools. If you go there, you're going to get your next breakdown. I mean, here you can kind of see how there's like a lot of, and this goes on, how a lot of different kind of links to different pages that have somewhat different versions of the tools. So for MHC class 1, this is what you're getting. You still have the same elements that you start off by inputting a peptide sequence. You select a prediction method. This is the same that I mentioned before. We have recommendations based on, and actually we put a date now here because these recommendations are expected to change over time as we update our benchmarks and new tools become available. That allows you then to run predictions in the same way, kind of like I showed you on the next gen site. For B-cell tools, and again, this is the only place where you can currently get B-cell tools on the IDB page until we release the next gen version of the B-cell tools. You have a distinction between linear, Discotope, ELIPro, etc. The linear epitopes are essentially the ones that are contiguous in the sequence of a protein. So this scans a protein sequence based on the sequence alone for areas that are having a sequence motif that matches kind of what is likely to be recognized by antibodies. You can run here the BepiPred 2.0 version. Actually, in the next gen version, we're going to have the 3.0 version out. And then you can essentially, over the amino acid sequence, plot the score that these different regions get. And you can identify here, you can actually see it visually that you have certain areas that have high scores above the threshold that you can choose and adjust that that could be potential epitopic regions. You get the same output here also in a table format where you have the specific regions called out. You can adjust these, recalculate, get different sequences out. And then you actually have here the different scores per individual residues. In contrast, you can use these structure-based tools. Here's the Discotope link. The input here is no longer just a sequence alone, but like a 3D structure. This might be a PDB ID that has been existing and published, or it might be your own PDB file, and you can model it. Again, in the new version, we're going to have integration of predefined, pre-made model structures based on AlphaFold and the like, which have been revolutionizing the field of structural biology. So you don't have to rely on the IDB, on the PDB alone. And then you have that kind of structure, and you can run it through a tool that first does something very, or here is presented in a very similar way to what the BepiPred one was showing, that you have individual parts here of the now linearized sequence of the protein. You got your scores per residue, but you can also, in a 3D view, show a 3D structure where then those residues are highlighted on the 3D model of the protein itself, indicating where the patches are that the antibodies might be recognizing. So here again, you have standalone local versions of the tools that you, as I said, exactly like before. The advantages are that you have privacy, but also, and I should have said this before, I mean, no internet needed. That can be an advantage. And if you have very, very large data sets, it is going to be much more efficient to download the tool to your machine and run things locally rather than moving your data back and forth to a server, to our servers, get the predictions and download them. It's going to be much faster to run things locally, even if you don't have a very powerful machine, just because the moving the data is going to be the limiting factor in several of these tools as you run them. So this is just an example of how calling one of these scripts look like on your machine. And with that, you're getting text files that look exactly like what you have as the output of the tool on the website. And so you can manipulate that directly. So with that, I think I'm done way too early, but that's okay. I showed you the classic side. I showed you the next gen side. We hope with the current release schedule that next year, when we do this again, there will only be next gen tools available, and hope maybe some leftovers, but this will be the focus. And so if you are currently working with the tools and are wondering which side should I pick, please immediately start using the next gen side, because that's going to be what's going to be taking over as we go forward. And please test them out. We're going to have the whole day tomorrow to talk in details about specific tools. And it would actually be fantastic if you have questions, maybe try them out today. And then if anything doesn't work, tomorrow is going to be a great time to ask questions and get answers. And with that, I am done.
Awesome. Thank you so much, Bjorn, for that introduction and re-emphasizing again, tomorrow we'll spend the whole 4 hours on the tools, which is exciting. And so we really consider the tools the other side of the IEDB coin, with the database being on one side and the tools being on the other. And I think that what Bjorn just presented is a really awesome example of how we listen to our user feedback. So the feedback that we got from users was that your tools are fantastic, but I think there are better ways to present them. And we really would like to be able to integrate tools in a step-by-step process, in a more pipeline fashion rather than all disparate. So that's where the next gen tools was born. And the team has had had a fantastic effort in re-implementing the tools. And as Bjorn said, the B cell tools should be around the corner. So by early next year, you should see them in there. And then really the bulk of our tools will be transferred to next gen.